Dear all, good morning and welcome to this important discussion on landfill remediation, exploring opportunities for adoption of Fukuoka method in Indian cities. We welcome all our panelists and guests who have joined us from different cities from India, various municipalities and government departments, and people who have joined us, various officials from other countries, to be a part of this webinar and discussion. Though we are all present remotely today, but I urge all of you to be participative in this webinar, to be a part of the polls that will be conducted during the course of this entire 2-hour session, and share with us your views and comments to take the discussion forward. Moving ahead, I will request all our attendees to take a short poll. This is only for the attendees. So can we have the poll? I think all of you must have entered your responses. So can we please publish the poll? Okay, so we have people joining us from government, a few non-government organizations, private sector, and a few from other departments. Thank you. I shall now ask Mr. Srinivasa Propuri, who's the Senior Human Settlement Officer with UN Habitat Regional Office for Asia and the Pacific, Japan, to share his opening remarks and kickstart this discussion. Over to you, Sri.
Thank you, Swati. A very good morning to all of you, and a warm welcome to all as well. And namaste to our Indian compatriots, and konnichiwa to my colleagues and friends from Japan. I'm glad to see the participation of officials from our partner cities and also other municipalities for this important discussion on landfill remediation. As friends, there are three important aspects that change the status of the world today. As you all know, it's about urbanization, industrialization, and an increase of economic status, therefore. So these three factors also increase the quantity of municipal solid waste, and it changed the way we behave, the way we produce, because of the change in our lifestyles. Okay, and the question that we ask ourselves today is how best we planned our cities in the past and still planning our cities now, and how do we manage our cities so that the adverse impact of those three factors, urbanization, industrialization, and the increase of economic status can be reduced. Okay, so without addressing these, we cannot secure, as you all know, the sustainable development. So in order to assist the national governments, cities, and the citizens, UN Habitat, along with our sister UN agencies like UNEP or UNEDO, we are working with the member states, we are working with academia and other think tanks to study, analyze, and capture good practices and also bad practices, and do's and don'ts, and sound practical solutions to the developing world. So in such journey, we found several affordable technologies on which we launched a Waste-Wise Cities campaign, and we are continuously conducting research and advocacy through State of Solid Waste Management in World Cities flagship publications. And in the recent past, we started translating these good practices from that philosophical normative policy perspective to actually practical on-ground solutions from one country to the other through South-South collaboration. And one such alternative technologies for effective waste disposal and treatment is Fukuoka method. Fortunately, I myself has been associated with the city of Fukuoka for the last 8 years. I've been living there. Right now, I'm in Hyderabad, working from home due to the current COVID pandemic. And my colleagues, Sachio and Professor Mash Fuji, who is joining now from Fukuoka, have been working with UN Habitat for several decades now in studying and also actually implementing, partnering with us, with the UN agencies and cities in replicating this in several countries. So as you all know, there are 6 functional elements of waste in cities, from the source to storage, the collection, transport, and treatment, and of course, ultimately the disposal. At present, we all know, on an average of 50 to 60% of the municipal budgets, be it a small municipality or a bigger municipality, of course, the bigger the more, and the budget is spent on collection and transport only. So even that with the collection efficiency of maximum 40 to 50%, rest being recycled or used or rack pickers or collecting it, or some being dumped in your backyards. So across the developing world, as you know, the open and the crude dumping is a major environmental concern and also a health concern, not only for the public, but also those who are dealing with that such hazardous waste. So, and the same case in most cities in South Asia and in India, although we see a lot of improvements in the recent past. So these crude dumping grounds also causing water pollution, and of course the methane gas emissions, and so the fire hazards, pests, rodents, the increase of rat population that is disturbing and also damaging the crops nearby, and causing a lot of environmental pollution for those settlements and habitat around that landfill site. So, and this is something that is completely opposite to a scientific engineered landfill. Okay, so the sound landfill management is obviously the need of the hour. We all talk about it, we all know about it, and without that, I do not see how we can get a clean environment and of course resilient cities that can actually contribute to not only for the resource efficiency but also converting our cities into more of the factors of that circular economy, and of course there is a lot of employment and growth that is involved within. Okay, so as I know, and many of you have been involved in many cities in India, we are conducting biomining. We are making a lot of efforts on biocapping interventions in several cities, of course. And these are all actually very expensive and magic solutions. It requires excessive maintenance costs. And so far, most of these are privatized in the way that they were given to private sector companies to actually recover that resource and ensure that they will get some income from it, so that at some point of time these will be transferred. And we really hope and sincerely hope that when they transfer, they would not become a baggage to our urban local bodies. So we have been studying these technologies and alternative technologies in several countries, and we found Fukuoka method is quite low cost and sustainable intervention in the landfill remediation. And we intended to see how these low cost technologies that we have witnessed and practiced in several countries can also benefit the Indian cities. Okay, so we as United Nations Human Settlements Program in Asia Pacific region, we are based in Fukuoka. That's one way, we are very fortunate to associate with the professor and Sachio, and also with the university and the think tanks. And we have been working with these professionals since late 90s. And we have had the chance to collaborate and work on this Fukuoka method and pilot interventions in many countries. And more importantly, that you will see in the video, how a recent disaster in Ethiopia, where a landfill collapse has caused more than 200 deaths, has now been renovated and revamped as a most sustainable landfill site using this Fukuoka method. And it's not costly in the sense that they have used the local material, local labor, and a lot of local resources. So on behalf of UN Habitat, I extend my warm and sincere welcome to our colleague, Honorable Prashant Gargava, the Member Secretary of the Central Pollution Control Board, for being available and also generously agreeing to give a keynote address for this important dialogue. I also extend my warm welcome to our colleagues, Professor Mashufuji-san and also Sachio-san. I must give some introduction to Professor Mashufuji. He has been the founding father of Fukuoka method. While his relation with the Fukuoka University and Kyushu University in conducting the research and also taking that from the lab to actually on the ground. And in the last 30-40 years, he has actually showed that all what we learn from the laboratories and the classrooms can actually benefit the society and also make improvements to the living environment around us. So with that, I really request all of you to actively engage in interactive sessions, listen carefully of the technologies and the methodologies that Professor is going to explain, and make sure that this important discussion will not remain as a discussion, but see how best some of your cities can start with that humble step of going forward, not only investing ourselves in that the source, how do we reduce the source so that 40 to 50% of the budgets can actually be saved from that collection and the transport by using composting or recycling or reusing, whereas in that journey you also invest similar amount of money on the treatment and disposal using the low-cost technologies like Fukuoka method. So I wish you a very fruitful discussion, and I hope we will witness at least a couple of cities from the discussion will embark on the journey. So thank you very much. Over to you, Swati.
Thanks, Sri, for kickstarting this important webinar. We agree that sound landfill site management is the need of the hour for transitioning to a circular, resource-efficient economy. With this important message, I welcome our keynote, Dr. Prashant Gargava, who's the Member Secretary of Central Pollution Control Board. CPCB has been instrumental in providing guidelines and releasing inventarization studies on the status of landfill sites in India, and key progress is made. May I request Dr. Gargava for his keynote address and to share with the audience, the general concerns and what have been the findings of CPCB on this matter. Over to you, sir.
Thank you, Swati. Good morning, Professor Matsufuji Yasushi from Fukuoka University, Japan. Senior representatives from Regional Office for Asia and the Pacific, UN Habitat, Mr. Srinivas Apuri and Madam Shashio Hoshino. Representatives from India Country Office of UN Habitat, Ms. Swati and Ms. Pooja, and other distinguished participants. Very good morning to all of you. At the outset, please permit me to compliment UN Habitat for all the good work that it has been doing for improving our lives, and particularly for organizing this webinar on an extremely important subject, specifically to India, and then giving me this opportunity to share some of my thoughts or share some of the information or inputs on the waste management in India. Waste management remained a challenge, but came into focus, much in focus, with revision of waste management rules in 2016, and also with Honorable Prime Minister's call on Swachh Bharat India. So that essentially brought waste management into focus. The good part about waste in India is that traditionally we have been reusing, recycling material and thereby minimizing the quantum of waste. If you look at the per capita waste produced, it's hardly 0.4 to 0.6 kilogram, which is much lower in comparison to the developed countries, wherein it could be as high as 2 kgs. But not so good part is that we have huge population. Therefore, the overall quantum of waste is much higher. Or number two, that we started a bit late on managing the waste. Another challenge that we have is, while we have to manage the freshly generated waste because there are not adequate secured landfill sites, at the same time, we also need to manage the landfill dump sites. If I can share some of the statistics, we produce roughly 150,000 tons per day of municipal waste. As I said that in 2016, new rules, and then with push under Swachh Bharat mission, almost 98% of this waste gets collected. But segregation remains a challenge. Only one third of 150,000 gets processed, and one third reaches to a scientifically designed landfill site. That means one third still goes to dump sites. So that is the kind of perspective that we have in terms of waste quantum and its management status as of now. Legacy waste, there are more than 3,000 legacy waste dump sites. In last 2 years, when CPCB brought in the guidelines, of course the guidelines talks about biomining of these dump sites, essentially trying to stabilize the waste, spin them out in different fractions, try and segregate and reuse and recycle to the extent possible, and then leftover to be disposed of in the secured landfill sites. So that's the model. Many of the places where reclamation of dump sites have initiated, this is the model that has been adopted. More than 500 cities have already started. In Indore, we had success stories. While we are looking forward to better technologies, low-cost technologies, the technologies that can remediate in a shorter span of time, because we have a large number of towns and cities which have such dumps. In terms of economics, even the biomining the kind of land reclamation that we get, it makes sense. In Indore, I'm told that they were able to reclaim about 100 acres of land. Now, in an urban area, having that kind of land will fetch enormous revenues and will be much more than the cost of remediation itself. So therefore, now there is an attractive proposition to the municipal bodies to try and reclaim the land and at the same time also get rid of this legacy waste. CPCB under the rules has been mandated to review newer technologies. While we have initiated, we want to put it on fast track, and we certainly look forward to newer and newer technologies, as I said, which can not only provide low-cost solutions, but also push our efforts and then try and get remediated these dump sites in the minimum possible time. So we certainly want to learn from experiences available elsewhere, and from that perspective, I'm glad that this Fukuoka technology is being implemented on pilot scale in 5 cities of India. We look forward to this evaluation. And as I was referring to the rules, CPCB has been mandated to review new technologies. So we'll request UN Habitat that in this 5-city experimentation, if CPCB could be associated, so that we are part of this entire process of learning, and also that will help us in evaluating this technology. And certainly, whenever we take up or whenever the new technology gets available, is proven, we certainly would like to consider updating our guidelines and making sure that all the possible technologies are available to municipal corporations in their efforts to remediate dump sites. So I'm glad that you organized this. I wish I could have continued for longer, but I will have to leave in between because of some other commitments. But we'll certainly join back. I guess it continues till 1 o'clock. So whenever I find time, I'll just try to come back and then listen to the discussions. But my colleague, Mrs. Divya Sinha, who heads urban pollution division that deals with waste management, will be part of the entire discussion, and then she will be interacting, will provide more inputs if needed, and will also try and facilitate discussion or give more insights from CPCB's perspective. So with this, I will close, and then once again my compliments to the entire team, and we look forward to this discussion. We will look forward to the new technologies that can help us in meeting the challenge of remediation of these dump sites. Thank you so much for inviting me. Thanks a lot, and wish you all the best.
Thank you so much, Dr. Gargava, for your important insights, and we shall definitely keep you updated on the proceedings of this webinar and our interventions ahead. Moving ahead, I will now ask my colleague, Ms. Pooja Verma, the Urban and Governance Expert with UN Habitat India Office, to share briefly with you our ongoing interventions under the Sustainable Cities Integrated Approach Pilot Project. Over to you, Pooja. Thank you.
Thank you, Swati. I'm just going to share my screen. Please confirm when you see it. Is it visible? Hi, is it visible?
Yes, it's visible.
Okay, thank you. Okay, so I'll take you through the project, the Sustainable Cities Integrated Approach Pilot. So the objective of the project is to integrate sustainable planning practices in the cities in their urban planning and management process, to show that if planning is done with a data-driven evidence-based approach, you can increase urban value, improve investment climate and service delivery, and build resilience in the pilot cities. Our pilot cities are Vijayawada, Guntur, Mysore, Bhopal, and Jaipur. And we have the representatives from those cities here today. So very warm welcome to you. So coming to the components of the project, there are 4 major components. UN Habitat is looking at sustainable planning and management. UNIDO is responsible for investments and technology. And the National Institute of Urban Affairs is doing capacity development and managing the platform for knowledge exchange for all the cities. So I'm going to break down the first component. The major outputs are the Sustainability and Resilience Assessment Framework for Spatial Planning in India. This would be applied to the cities to develop the city profiles and diagnostic, and that would lead to the Sustainable City Strategy and specific actions and interventions. And finally, the Spatial Database for Continued Assessment that will enable the cities to run different scenarios in the future and test the impact of the potential projects that they want to implement in terms of their overall impact in the city. So coming to the output 1, this assessment framework is geared for spatial planning and being developed by assessing select existing global and national frameworks. And the indicators cover sectors including mobility and accessibility, density, disaster, health, sanitation, waste management, and so on. The idea is to understand how the city is performing on these parameters and benchmark them to the global and national best practices. And this framework would be scaled up and rolled out at the national level for other cities so that it can inform the strategic direction and spatial growth of the cities. The second output is the city profiles and diagnostic. These would be created by applying the assessment framework that we are currently developing and then identifying 3 to 5 main sustainability resilience aspects that the city needs to address and examine the underlying causes for the indicator's performance compared to the benchmarks. So on the right side, these are just some example diagrams here. And it's not to say that these will apply to our project cities. We have a map looking at walkability and job accessibility. So in the diagnostic, the spatial analysis would show things like the population distribution, and then where are the jobs concentrated, what is the accessibility that people have to essential services, to clinics, to schools, to economic hubs, or to public transportation. Within a 10-minute walking distance, for example. So that brings me to output 3. Output 3 is the Sustainable City Strategy. So from the diagnostics and consultations with the cities, the strategy would identify strategic areas for intervention and investment. It would provide critical spatial and development interventions to address the main issues. It would analyze the current and proposed development scenario and how that would impact the city's future. And the strategy would also include a methodology for strategic spatial planning and capacity building for the stakeholders. So in this example, on the right side, the strategy of urban density, the indicator shift is the increased density in the city in the future. And that density increase would be at the right places to direct investment and planning together. Coming to output 4, which is the actionable next steps. These are the implementable interventions that would be identified with potential projects that could be taken up, being backed by data and evidence for the reasoning, and show how it will shift the indicators to go towards sustainability. This would also include handholding for cities to adopt and to institutionalize the methodology and build capacity of the cities and regulatory tools for this type of data-driven planning and management. So this is basically the summary slide highlighting the iterative process that we are following in the project for all of the outputs. The entire 3-year project is a process that has a feedback loop with the cities that we are working on and with all the stakeholders. And the main outcomes are strategic projects and interventions that we can identify in partnership with the cities, and then investors can be brought in to develop those projects with the cities. Thank you. Over to you, Swati.
Thanks, Pooja, for a very short and brief presentation on the work that is happening here. May I now ask all of you to take another poll, which is what is the main reason for mismanagement of waste in your city? So kindly fill the poll. So we see that broadly in cities, sometimes it's lack of segregation incentive mechanisms which lead to mismanagement of waste systems, or it's lack of administrative will, or probably sometimes the infrastructure does not support effective and sustainable waste management, or is it lack of robust policies or bylaws at city level to ensure compliance, or you feel is it all the above? So kindly enter your answers. Okay, so I'm assuming that all of you have filled up the poll. May I now request the admin to publish the poll? Okay, so many of you feel that all the above reasons are responsible for mismanagement of waste in cities. Some of you feel that it's infrastructure. Some feel it's lack of segregation incentive mechanisms, and some feel it's lack of administrative will. Okay, so moving ahead, I think before we move ahead with the main presentation with our Japanese experts, maybe I'd like to give a brief presentation on the existing status of landfills in India and what are the major interventions taken. Yeah. Okay. So can I get the screen sharing? Yeah. Is this visible to all of you? Okay. So looking at where we are in India with in retrospect with waste management, we clearly know that due to Swachh Bharat mission, there is a paradigm shift in awareness and involvement of various stakeholders on issues related to waste management. But as CPCB member secretary also stated that a lot more work is required, firstly on source segregation and on processing. One important thing to note here is that segregation was earlier considered as the main compliance condition. Earlier, decades ago, when we had our municipal solid waste management rules, which stated that the mandatory condition for every urban local body was to have a sanitary landfill site. But there was a leapfrog in approach, and the present rules of 2016 clearly say that every effort has to be made to recycle or reuse the rejects to achieve the desired objective of zero waste going to a landfill. So of course, there is an emphasis by the central and state authorities to reduce landfilling and to ensure that there is sustainable landfill management. Coming to where we are with waste management, of course, we clearly know that waste generation growth is outpacing population growth by 2 to 3 times. It's likely to double in next 10 years. We are somewhere around 62 million tons per annum as per official figures, but we clearly know that the numbers are much higher because most of these values do not add up the waste managed by informal sector. But we clearly know that as we are becoming more prosperous and developed, the waste generation patterns are also increasing. Coming to the important question of landfills, every city, every ULB wants a landfill or they have numerous dump sites, but where is the land? As per various estimates and as per the official 2016 estimates, India added about 31 million tons of waste to the legacy waste in its dump sites. As per a recent World Bank report, which was Water Waste 2.0 that came last year, it said that in South Asia, about 3/4 of the waste is dumped in open dump sites, which is quite alarming. Another figure that I'd like to shoot at you is that if we keep on dumping the way we are, by 2047, we'll reach a time when we would need land the size of Hyderabad, Chennai, and Mumbai added together to dispose of our waste. And as per CPCB's latest data on dump sites, a report that came last year, India still has about over 3,000 operational dump sites. Most of them are in Uttar Pradesh, which tops the charts with the number of dump sites, followed by Madhya Pradesh and Maharashtra. If you look at what are the interventions that are happening in India in terms of remediation of these open dump sites, or what we call landfill remediation, it's majorly limited to landfill capping and biomining, which are considered to be the two most solutions that are being practiced on the ground in various cities. We know interventions have been happening in Indore, in Mysuru, in Vijayawada, quite a few cities across the country. But most of the interventions are limited to biocapping and biomining. If we look at, what are the basic differences in the two technologies, with biomining and bioremediation, majorly they claim that the land can be used for alternative purposes after 15 years. But with biocapping, the land cannot be used for purposes other than parks or landscapes. And leachate and landfill gases generated are to be managed for various biocapping interventions, and it requires maintenance for at least 15 years. So clearly, biomining and bioremediation based interventions are also the interventions that are being widely acknowledged and practiced across the country. Coming to how feasible it is, of course, there are cities who are doing it. Delhi is doing it, and many other cities, about 15 to 20 cities are doing various operations on biomining. But what is the economic viability of it? If we look at it, the operational expenditure of biomining and bioremediation depends on the size of the dump site. And the major players in biomining, they're using programmable logic array-based systems to regulate the flow of stabilized waste from one trommel to another. And the capital cost of mobile equipment with capacity of about 700 tons per day is estimated to be around rupees 10 crore. And the average cost of processing 1 ton of legacy waste is around 750 to 900 Indian rupees. This is depending on the age of the dump site. So clearly we can say that the capital and the operational costs are quite high for all these interventions, and they typically involve utilizing a private party or a concessionaire who comes to a city, sets up the instruments that are required to sieve and set up the entire system to manage such sites. Taking you forward with an example of an intervention that has happened in Vijayawada, where existing dump site was remediated. So as we can see that over 250,000 metric tons of waste was cleared from this site. You can see the before and after pictures, and about 45 acres of land was remediated over 3 stages, which was pre-stabilization, sorting and segregation, and disposal. And the project took about an year for reclamation of land. If you can see, these were some of the interventions, that after segregation from such a facility, the fine soil is typically used for afforestation purposes. There's still some soil which is not that, good and cannot be directly used for any horticultural based practices, but it could be used for filling in low-lying areas. Stone is used for road construction or for embankments. Most of the combustible fraction that comes out from legacy sites could go to cement factory or incineration plants. The metal scraps and glass scraps could go in for recycling. So majorly, this is the protocol that is being followed. And you can see clearly the pictures after pre-stabilization, reclamation, and how the site looked before and after. But there are a few challenges that remain, and I'll leave with those questions. One is that urban waste management is expensive, and waste management, it can be, if we look at municipalities in India, typically municipal budgets account for only 10% for solid waste management. And many municipalities lack this budget to opt for landfill remediation. So probably a small city in Bihar, which has an issue of dump sites, or a small city in UP, which has a major issue of dump sites, won't be able to go for such technologies because probably they don't have the bandwidth or they lack budgets to take these interventions forward. There's also an urgent need to look at affordable and effective integrated solutions for landfill site management. And in the Indian context, we basically need more solutions for dump site landfill management, focusing towards utilization of local resources, which emphasize on segregation and which look into recovery of recyclables and provide jobs to the informal sector, which is critical. So with this, I'll close my presentation and maybe take now a short poll, which is basically on what is the kind of landfill or dump site remediation or interventions that are happening in your city. So can we kindly publish the poll? So please take your time to fill up what are the kind of landfill dump site remediation interventions happening in your city. Is it bioremediation? Is it biomining? Is it biocapping? Have there been some interventions on gas collection or release, or on leachate collection, or there is no intervention happening at all? Okay, can we publish the results of the poll? Okay, so in major cities, bioremediation and biomining is happening. In some cities, biocapping related interventions are happening. In some, gas collection or release interventions are happening. And I think in many cities as well, no intervention is happening. Okay, so I think now with this, with this result, maybe we come to a very important point of, the webinar. Before we introduce Professor and Sachu, maybe we'll see a small video presentation on Fukuoka method. I think since the start of the webinar, we've been talking about Fukuoka method. So let's go ahead and see a small video on what is Fukuoka method and where all has it been implied.
The Japanese islands, situated on the western rim of the Pacific Ocean. Fukuoka City, located on the northern part of Kyushu, one of the Japanese islands, has a population of about 1.3 million. As one of the leading cities in Japan, this metropolis continues economic development, but in spite of its million-person population, still maintains an excellent urban environment. From the late 1960s through the 1970s, however, Fukuoka City faced severe problems related to the management of waste generated by this economic development. At that time, most waste was disposed of through simple landfill, and landfill management efforts were unable to keep pace with the influx of waste. The landfills generated noxious odors, contaminated leachate, and methane gas, and often suffered major subsidences. To resolve these problems, Fukuoka City constructed a series of intermediate treatment facilities, and at the same time launched a joint research program with Fukuoka University. Today, these efforts have resulted in landfills maintained in excellent condition. Let's take a closer look at the Fukuoka method. Fukuoka University noted the importance of air and microorganisms in the landfill waste layers, and classified landfills into 3 types. The conventional anaerobic type, the semi-aerobic type, and the aerobic type. The concept of the semi-aerobic landfill was developed and proposed by a group led by Professor Masataka Hanashima of Fukuoka University. After the concept was demonstrated through practical trials implemented jointly by Fukuoka City and Fukuoka University, it was christened the Fukuoka method. The basic structure of the Fukuoka method landfill is a network of perforated pipes with a sufficiently large cross-section laid across the bottom of the landfill. This design not only prevents leachate from stagnating in the waste layers, it also utilizes the thermal convection currents generated by microbiological reaction within the waste to draw outside air into the landfill through the drainage pipes. This flow of air promotes biologic activity by the aerobic microorganisms, which improves the quality of the leachate flowing through the waste and suppresses the generation of methane gas. The Fukuoka method has an extremely simple structure and is simple to maintain and manage in operation. Based on fundamental research initiated by Professor Masataka Hanashima in 1966, the first trials of the Fukuoka method were held in a large concrete container. Initial results were good and led to large-scale testing at the Hisayama landfill site as consigned research from the Ministry of Health and Welfare for a 3-year period from 1973. The tests demonstrated that the design has a significant effect on leachate quality. Based on these test results, Fukuoka University formally proposed the new semi-aerobic landfill type. Fukuoka City responded by adopting the new landfill design in its Shin-Kamata landfill site as the first implementation of semi-aerobic landfill technology in Japan. The Busetsugaura landfill site was designed and constructed as a full-scale semi-aerobic type. The research and full-scale demonstration were well received throughout Japan, and a number of local governments adopted the semi-aerobic landfill technology as a result. By about 1975, the new technology was widely known as the Fukuoka method. Today, the Fukuoka method has established itself as the standard type of landfill in Japan. Fukuoka University has continued to develop a variety of landfill structures and systems, and tests are yet underway to further enhance and expand the functions of the landfill. Fukuoka City has incorporated these improvements in the construction of its Fushitani and Nakata landfill sites. Here are the major components of the semi-aerobic landfill type. The floor of the landfill is equipped with leachate collection pipes and gas ventilation pipes. The leachate collection pipes are perforated plastic pipes, surrounded with a sufficiently thick layer of small stones. Most of the waste disposed of by landfill in Fukuoka City is non-combustible waste, and therefore the gas ventilation pipes are installed at a 40-meter pitch. This pitch would have to be tightened up for landfills with larger ratios of organic materials. The Fukuoka method can be implemented throughout the Asian Pacific region at low cost. Professor Yasushi Matsufuji of Fukuoka University, dispatched as a long-term expert by the Japan International Cooperation Agency, JICA, spearheaded the transfer of Fukuoka method technology to the Ampang Jajar landfill site in Malaysia as the first trial of the method in Southeast Asia. In this landfill, leachate collection pipes were fabricated out of locally available bamboo. And the leachate was recirculated to further heighten the water cleansing effect. Water quality was improved significantly by reusing waste activated charcoal, also available locally. A variety of gas ventilation pipes were used, made of assemblies of wood or bamboo, stacks of old tires, and steel drums. The Fukuoka method can be implemented using materials readily and inexpensively available in each locale, making it a simple, convenient technology with a wide range of application. This landfill site was rated highly as a successful example of an ODA-sponsored JICA project, and has attracted considerable attention not only in Southeast Asia, but also in Central and South America. Habitat, the United Nations Center for Human Settlements, opened its Fukuoka office in 1997 and requested the assistance of Fukuoka City and Fukuoka University in an ongoing project in the Islamic Republic of Iran. The project focused on methods of controlling the emission of methane gas, classified as a greenhouse effect gas, from landfills in that nation. One noteworthy point about the new project was that the connection boxes on the leachate collection pipes and the gas ventilation pipes in the landfill were made of brick, a material readily available in Iran. The completed project is being monitored in operation now, and expectations are high as it marks the first application of the technology to the Middle East. Training workshops were also held for local engineers. Habitat is an official agency of the United Nations, established to contribute to an improvement of the residential environment for human beings. The Fukuoka office focuses primarily on the Asian Pacific region. Habitat recognized the advantages of the Fukuoka method in improving the environment around landfill sites, and is actively promoting it throughout Asia and the Pacific.
The Fukuoka method is a way to work with nature to reduce the impact of landfill sites on the environment. At the same time, it is a technology that does not require high capital investments or highly trained specialists. For these reasons, it is the most appropriate technology for developing as well as developed countries. We appreciate the advantages of the Fukuoka method and will continue to encourage countries in Asia and the Pacific to consider adopting this technology.
Former landfills in Fukuoka City today hold a range of facilities widely used by the residents, including a special school, the Citizens Refresh Farm, and an athletic park, while long-term monitoring continues for items like gas release, subsidence, corrosion, and other environmental concerns. The utilization of the Fukuoka method provides rapid stabilization of the landfill and contributes to the construction of a comprehensive recycling society, including the reuse of land resources. The cooperative research and development by Fukuoka City and Fukuoka University has also helped establish the field as a subject for academic research. The Fukuoka method will continue to contribute to our lives as a fundamental technology supporting sustainable development.
So I think the video kind of gave a visual of what is Fukuoka method and how did it origin. But now I'd like to welcome Professor Matsufuji Yasushi, the founder, one of the founders of Fukuoka method, which is now a standard landfill method in Japan. It's practiced by over 80% of local governments throughout the country. And Professor has advised over 15 countries for development of municipal solid waste systems by introducing Fukuoka method. He has also trained many government and local government officials in over 100 countries, sharing with them this intervention. So we welcome you, Dr. Matsufuji, for your time. and for agreeing to be a part of this important webinar. I'll also welcome Sachio Hoshino, who's a special advisor to the Director, UN Habitat Regional Office for Asia and Pacific, Japan. And I'll now give the stage to both of you to share with us, firstly, the professor who will introduce us to the Fukuoka method, and then over to Sachio, who will share the various interventions undertaken in different countries in Ethiopia, Kenya, and Myanmar on this method. So over to both of you.
Okay. Yes, ne? Okay. So, sorry. Thank you very much for your introduction. 聞こえます？入ってます？ Good afternoon, ladies and gentlemen, especially Miss Swati. And thank you very much for coming to this webinar today. It is my pleasure and honor to speak for our friends in India and through the online. My name is Yasushi Matsufuji, Professor Emeritus of Fukuoka University, and now also President of NPO Solid Waste Advisor Network Fukuoka, so-called the SWAN Fukuoka. Next. In this webinars today, I would like to talk about 変わりません？うん。
Next slide, please.
Next slide. 動かないね。これかな。向こうで操作しないとダメ。ん Next slide, please. Okay. So, and in this webinar today, I would like to talk about Fukuoka methods as introduced by the moderator. I think many of you are hearing Fukuoka method for the first time today. So I would like to begin with the history of the solid waste and development of Fukuoka methods, then the technical future. Later, Ms. Sachio Hoshino of United Habitat Fukuoka office will speak about the application of the Fukuoka method in the country in the Africa and Asia. Next slide, please. First of all, I would like to first explain the Fukuoka method is a semi-aerobic landfill type. It is cost-effective, simple to build with local material and manpower, eco-friendly. It will fit into many different conditions and context of many countries. Fortunately, I am working with many countries and was able to improve the solid waste condition through the introduction of the Fukuoka method as an entry point. I'm sure it is suitable to India also. Next slide. I will begin to the year when the city first faced the problem of solid waste management with rapid economic growth and population increase similar to current India. Next slide, please. Look at the photo. The photographs are from the Tokyo in 1960s and 1970s. They explain how waste was collected in Tokyo in the first Olympics Games in 1964. Capital city of Tokyo had the open dumping site which developed in the islands and near the Haneda International Airport. It was named Dream Island, but its reality was open dumping and caused many problems such as endless fire, massive fires covering the nearby the community and schools. In 1971, the government of Tokyo declares the garbage war, which became the starting point to the overcome municipal waste crisis. Next slide, please. Coming closer to Fukuoka city, it was also experienced a population increase and urbanization in 1970s. The city was having the difficult time handling increasing amount of the waste. As you can see the photograph, fire was breaking out and extinguish fire was the city major work every day, shown this photo. Next slide, please. Under these conditions, Fukuoka City government and Fukuoka University, my university, decided to undertake a study on solid waste landfill, which was the first of its kind in Japan. Next slide. The research study was a joint effort and strong initiative by Fukuoka City and Fukuoka University for over 3 years from basic study to advanced level. Research on biological biodegradation of waste layer placed in the wooden rice meter in aerobic condition using the air blower. This is considered the first and one of the most successful models which led to the development of Fukuoka method. Next slide, please. Look at this figure. This and the graph shows the changing in the leachate quality generated from the waste rice meter. From this experiment, we can see the BOD and nitrogen, total nitrogen concentration rate was larger reduced by blowing air into the landfill model rice meters, shown in this slides. Next slide, please. The test rice meter were dismantled after 3 years of experiment. The two photos of the right side show the waste condition after 3 years since it was landfills. Look at this photo. Top photo shows the waste degradation without direct air blowing into the waste layer. Bottom photo shows the waste degradation with air blowing. Waste degradation result was obviously different with or without air. You can see that these are two photos. Next slide, please. After the positive result by the rice meter test, a larger actual scale landfill test started in 1973. This was a feasible study of the aerobic landfill type with two large sites demonstrated plant, each with 40-meter cross, was 40-meter width cross 5-meter height. This monitoring with organic waste continues for further 3 years. Next slide, please. As a conclusion, we were able to propose a new landfill concept. It means that if a landfill is an aerobic condition, the landfill not only function as a dumping site, but also can function as effective treatment tanks. From these large site demonstration plant, we were successfully in proving on the effectiveness of the new landfill concept under aerobic landfill types. However, the research concludes aerobic landfill use a blower was not practical in real situation. The reason were that the construction and maintenance cost was too high and maintenance was very difficult. However, during the experiment, we happened to encountered a new discovery. We often said that fail teaches success or negative discovery is hidden in new discovery is hidden in negative data. While striving to find the causes of the negative data, we found the new waste decomposition mechanism, which later become the basis of Fukuoka methods and propose one hypothesis. This is a semi-aerobic landfill type. Presently, it is known as a Fukuoka method worldwide. Next slide, please. From here, I would like to talk about the mechanism of the characteristic of the semi-aerobic landfill type. The top drawing in the traditional landfill model, the bottom drawing the a new landfill model using the new semi-aerobic landfill type. Semi-aerobic landfill type installs the perforated leachate collection pipe at the bottom of the landfill in order to effectively collect leachate as soon as possible. Through the leachate collection pipes, leachate in landfill is swiftly removed to the outside of the landfill. At the same time, fresh air naturally flows into the waste layer from the bottom of the landfill. This is due to the fermentation heat and convection effect generated by microorganisms' activities in waste layer. By applying the mechanism, even without power blower or electricity, a landfill are naturally able to improve itself to aerobic condition by the install of leachate collection pipes in the bottom of the landfill. Next slide, please. This and look at this figure. And this graph shows the semi-aerobic landfill type is able to reduce 90% of BOD concentration rate of low leachate from landfills and is equally effective to aerobic using the blower. Next slide, please. This drawing shows the mechanism of the airflow from the leachate collection pipes at the bottom of the landfill. It is similar mechanism to the traditional cooking oven. The fermented heat generated during the waste decomposition by microorganisms causes the convection flow entry to the causes air flows, shown this slide. Next slide, please. This is a photo of the Fukuoka and the methods landfill in Fukuoka City today. The landfill has been improved dramatically and it is more sophisticated form. The one in first developed 40 years ago, but the basic concept is the same. Today, the Fukuoka method is a standard model of the landfill in Japan, and it's used by about 80% of local government in Japan. Next slide, please. I think you already understood by in the video show, the landfill after complete and close are also use the park, school, and rental farm shown this slide. In recent years, the technology of Fukuoka City to improve existing landfill have been well recognized internationally, and people come many countries in the world, including Asia, visit Fukuoka and Fukuoka University to take a training every year through the JICA or UN Habitat, as you know. So next slide, please. Already mentioned this video. The first initiative was a technical transfer of the Fukuoka method in Malaysia. At the time, I was dispatched a long-term expert of JICA, Japan International Cooperation Agency, to Malaysia for 2 years from the 1988 to 1990s, and worked on the improvement of the existing landfill using the semi-aerobic concept. This was the first technical transfer of the Fukuoka method to overseas. When I just arrived in Malaysia in 1988, the situation from the photo, very dirty. Every day is just open dumping, the open burning. As you can see, the terrible situation from this photo. Upon the introduction of Fukuoka method into the landfill, we are able to improve with a low cost and within a very short period. Next slide, please. From this example, you would understand the Fukuoka method is technical to improve the landfill condition in the various stages of the countries, even is in countries with lack of the 6M. That means the money, lack of the money, manpower, and material, and management, maintenance, and motivation. We call the lack of the 6Ms. Every country faces a very same situation, I think. The Fukuoka method is also possible to improve their landfill by step. The photo shows the progress of landfill improvement in Malaysia case study. Recently, in Japanese government and United Habitat highly evaluated this Malaysian project for our one of the success story based on the semi-aerobic landfill concept. So next, I would like to change the excellent presenter to the Miss Sachio, please.
Thank you very much, Professor. I hope everybody can hear me. From here, next slide, please. May I ask for the next slide? Thank you. From here onwards, we would like to take you through the application of Fukuoka method in various countries, as you see in the map here. We hope that at least some of them will be relevant to the context of the participants from India today. Okay, next one, please. We are currently handling the application of Fukuoka method in a number of solid waste management related projects in Africa and Asia. And only in the last 1 or 2 years or so, I was fortunate enough to travel to over 10 countries with Professor Matsufuji. Traveling is nice, but however, the reasons why we have been invited to many countries is because there are issues and it was quite alarming. We are seeing in many countries increasing urbanization of waste. The volume is increasing, the composition of waste is changing, and due to increasing amount of heavy rain at one time, not just heavy rain in total, but heavy rain at one time, there are increasing incidents of accidents at the dump sites, such as fire, gas explosions, and landslides. This is in addition to the already existing issues such as leachate and contamination of land and water bodies. And what is also alarming is that this is occurring everywhere, not just in tropical climates, but in Africa and Asia as well. Could we come to the next slide, please? Thank you. Now, again, this is one of the main reasons why we are invited and called to assist these countries and cities. As you have just heard from the professor, Fukuoka method was found to be beneficial and practical to many countries for these reasons. They can be applied at low cost with simple technology, and it is proven to be environmentally friendly. And in particular, which we think it is quite applicable to the context of India, is that open dump sites could be properly and safely closed and to be used for other purposes. And it is able to utilize local materials and manpower, which contribute to job creations and skills development of workers and operators and waste pickers. And most of all, it is possible to start from any stage of the dump site, whether to start from scratch, from planning and design, or to improve a 40-year-old or 50-year-old de facto dump site and convert into a Fukuoka method sanitary landfill. Next slide, please. From here, I would like to quickly share snapshots of Fukuoka method applied in many countries in varying contexts. First one is Iran, which you already saw in the video and from Professor, to show you that it is also applicable in very arid and desert dry climate. Next one, please. Thank you. The next one is the Pacific island of Samoa. It is to show you that it is also possible to address island context, which is sometimes very difficult. Next one, please. Next one is in China. This is an example of a university-to-university academic study and relationship which led to this project. It was a joint research done by Fukuoka University and Tsinghua University in China. Next one, please. This was a project in Pakistan, which I believe the climate context might be relevant to many cities in India. Next one, please. And this photo is a small pilot scale project undertaken in Vietnam. They have planted, after it was completed, they have planted papayas and fruits after the closure of the pilot scale, and it is growing beautifully now. Okay, next one, please. Okay, from here I would like to introduce our recent projects undertaken by UN Habitat under technical advice of Professor and his expert team. This is in Kenya, in the suburb city outside of Nairobi, the capital city. This is right after the Fukuoka method landfill was just completed. You can see Professor and myself in the photo. It may look different from the photograph shown to you earlier from Professor. Of course, it is not as sophisticated as the one you saw, but the basic concept, the core function, and the effect is just the same. And what I wish to share with you here is that only 10 months before this photo, could you come to the next slide, please? Thank you. The state of waste was like this. In less than 10 months, we were able to push the waste and utilize this as embankment of the landfill and constructed the new Fukuoka method landfill, the very first new model in Africa. Next one, please. Thank you. The next project is in Ethiopia, which is still ongoing now. This was a dump site in Addis Ababa city. For over 30 years, this was the only dump site which served the entire capital city of a population of 3.3 million. The size is roughly 42 hectares, and the height at the highest point is 50 meters. You can perhaps see the tiny small, can you come back to the previous one? Thank you. We're still on this one. You can see the tiny person standing at the top of the dump site mountain. It's how big this. It shows how big this dump site is. What happened in the year 2017 was one side of this dump site mountain collapsed due to heavy rain and perhaps gas explosion. It took the lives of estimated 200 people, mainly the waste pickers living on the slopes of the dump site and the neighboring communities down below. Upon request of the government of Ethiopia in Addis Ababa city, UN Habitat worked on emergency rehabilitation of the dump site and to prevent any further similar landslides and also to stabilize the slopes using the principles of Fukuoka method. Can we come to the next one, please? So this is basically a before and after photographs of the collapsed side of the dump site. Again, under technical advice of Professor and his expert team, as you can see, the side was stabilized, and we were able to do this in roughly 4 to 5 months. The next slide, please. Okay, let me explain to you what I mean by using the concept of Fukuoka method. The slope was improved into terrace steps. Then gas ventilation pipes were installed, which allowed release of methane gas, and at the same time, it pulls in fresh air from the gas venting pipes into the waste layers, which accelerates the decomposition of waste and leachate generation. The leachate was collected and diluted into a collection pond, which was constructed at the bottom of the waste layers. Next one, please. This is a photograph looking at the completed slopes from the bottom, from the ground level. You can see the gas venting pipe, the white gas venting pipes installed on each of the waste terrace steps. This photo was taken 4 months after the project completion, and you could perhaps see little greens already starting to sprout in some areas due to aeration and also decomposition of waste. Next one, please. This is another 2 months later. Yes, thank you. Greens are already starting to cover a large area of the improved slope. This is still waste underneath, as you know. So we are also working with the city administration to plant trees and vegetables on the slopes for generation of income for the communities. And also a windrow compost plant is being built on another side of the slope to treat market organic waste. And this will create better stable income for the former waste pickers as well. Next one, please. Thank you. This is another dump site improvement project we are now undertaking in another city called Bahadal in Ethiopia. Before our intervention, it looked like any common uncontrolled open dump site, as you see on the top. Now it is close to project completion, and below is a drone photo of how the embankments were constructed using old dump waste. When I mean by using old dump waste is that you don't need to purchase fresh soil every time to do the construction. You can utilize recycled materials. Next one, please. During the process of our project, we always work together with the waste pickers. In the dump site in Addis Ababa city, there were estimated 2,000 waste pickers at the peak. I'm sure many of the cities in India would share the same issues. It is very difficult and sometimes very high risk to operate the dump site in safe and peaceful cooperations with the waste pickers. We try to undertake training for the waste pickers and the vehicle operators. If done properly, this will raise safety and efficiency level of waste pickers picking waste properly. And at the same time, this will improve the spreading and compaction of waste by the backhoe and excavator operators. This spreading and compaction will make a huge difference in prolonging the lifespan of the landfill site, and it becomes more stronger and resilient to heavy rainfall in the long term. Next one, please. Another recent project we are currently undertaking is a bit closer to India. This is in Yangon city in Myanmar. This is another capital city dump site with a total size of 120 hectares. It caught fire, a major fire, possibly due to combination of gas release and perhaps waste pickers putting fire on rubber tires or things like that. The fire went on for more than 3 weeks, which became a major risk for the city, and we were called to rehabilitate and improve the situation. So far, the dump site is formed into cells with firewalls, so that even if a fire should break out, it will not spread into the next cell. Again, here, gas venting pipes are being installed to release the methane gas and to accelerate degradation of waste, and to build drainage ditches to capture the leachate and rain in the monsoon seasons. In the current COVID situations, visiting the site, traveling to the site is not possible, unfortunately, so we are undertaking online video meetings with Yangon City partners and UN Habitat Yangon office every week to monitor the progress and provide technical inputs. Next one, please. In every landfill improvement project that we undertake, we also undertake on-site surveys and monitoring of gas and leachate. As you see in the photographs, this is from Myanmar. We try to demonstrate the mechanism of process of leachate treatment and how it can be improved. Next one, please. I am nearly at the end of my presentation. Again, the key takeaway message we would like to extend to all partners today is that among various methods and technologies on treatment of waste, the strength of Fukuoka method lies in its ability to reduce pollutant of leachate, to reduce methane gas emission, and it allows us to reuse and recycle the completed landfill as precious piece of land, in particular sometimes in city centers. Next one, please. And it is also possible to do so in a simple and low cost and environmentally sustainable way. And next one would be our final slide. Thank you. Today, we only have time to explain about the Fukuoka method itself. And of course, we fully realize that building an efficient landfill does not solve all of the problems of waste management. However, we have experienced in many places that this has been a very effective entry point, or to revisit the entire system, or a leverage point to either kickstart or accelerate the improvement process. So I hope this information was useful for you as well. Thank you very much, dear participants, and we look forward to further discussions. Thank you.
Thank you so much, Sachio and Professor Matsufuji, for sharing with us the wonderful case studies and also explaining to us the Fukuoka method and its application. Now we come to the most important part, wherein we take a few of your questions and queries. I can see already on the question board, there are a lot of questions. So maybe we'll take a few questions from cities that are participating today, followed by a few questions that are there on the GoTo dashboard. Can I ask our admin to connect to Ravi Krishna Raju from Guntur, who can ask the first question to Professor and Sachio?
Can this method can be immediately used for treating legacy waste in the dumping yard, sir? Sir, am I audible?
Yes, you are audible. Can you repeat your question again?
Yes, can this method can be taken up immediately for treating legacy waste, or does it need any prerequisite treatment process?
Thank you, Mr. Ravi.
Not audible, madam.
Thank you. Thank you for your question. Sachio, this question comes from Guntur, one of the cities in India. And they're asking that can Fukuoka method be taken up immediately for treating legacy waste? Or does it requires any processing or pre-treatment before you take this up?
Legacy waste meaning old waste, no?
Yeah,
yes,
exactly. Yes, okay. Existing waste.
奥もちろん、はい、もうニューでもイグジスでも、むしろするんだったらイグジスのランドフィルから着した方がいいと思います。
The answer is yes. It is able to treat, start from any state, as I explained in my presentation, whether it's a 30-year or 40-year-old waste, it's able to treat old layers of waste as well. And we have seen in many cases that even in old waste layers, there's still plenty of methane gas and trapped inside. So it will be a very effective way to use Fukuoka method to start to improve old layers of waste as well. 先生どうぞ。
いや、スライド見せれたらね、マレーシアのプログレスありましたね、10年の。あれ見たらまさにイグジスのランドフィルを改善して、あれが一番いいです。 出せるかな。
Sorry, Professor was also saying that if you remember the slide from Malaysia, over the year it has improved significantly. And that is also an existing dump site. So he started from treating old waste as well. So it works just the same with treating old waste and new waste.
So, and,
Thank you, Sach.
I just mentioned to the every in the developing country face a very serious issues for the lack of 6 M's. So many local government face a lack of the money, manpower, material. So I every time stress the first step and the priority is from open dumping of the and open burning to the sanitary landfill site. The second priority is from the sanitary landfill to the Fukuoka method, design the Fukuoka method. Finally, is third priority is leach treatment and process, like a step-by-step progress. It is very useful for the many local governments, because this is my concept. Okay.
Thank you, Professor Sachu. We'll take one more question, which is from Sarda Devi from Vijayawada. Over to you, ma'am. Can you please ask your question?
Hello, everyone. Since just now Additional Commissioner Sharada Devi, she just went for a short call for other meeting. So on behalf of her, I would like to put forward this question. So what would be the specific minimum requirements for implementation of this Fukuoka method? Since in case of Vijayawada, we have this already, we have this biomining plan. So are there any specific requisites that we need to have in place to implement this method in case of Vijayawada? Yeah, that's it. Thank you.
Thank you very much for the question. Correct me if I heard wrongly. You were saying that you already have a dump site, a biomining in place, and is it also possible to intervene with Fukuoka method from there, and what are the specific requirements to do so? Was that the question?
Yeah, Sachu, they're asking, Vijayawada has already undertaken a landfill remediation process. So how in such a scenario, even this intervention could help? I hope I've got it right. Yeah.
Yes, of course. We would need to know more on what is the state of the waste, especially how the biodegradation, how the decomposition is going. If there's any drainage or leachate collection as such ongoing. If there isn't, we can introduce the basic, we can start from anywhere, as we have been trying to explain. We can start the intervention by installing gas ventilation pipes to accelerate the decomposing process. If possible, we can construct a leachate collection facility nearby so that it is not to make sure that it is not polluting the surrounding the land and the nearby.
Thanks, Sachu. I'll take a few questions which have come on our dashboard. This question comes from one of the state's municipal urban board, Goa, and they're asking that, after collection of leachate, what is the method for treatment and disposal under Fukuoka method? Yeah, over to you.
From my opinion, and already, if you will accept the semi-aerobic landfill concept, so the low leachate quality is very low, about 90% cutoff. So is very that means leachate treatment is very simplified, can simplify. So we introduce many type of the leachate treatment system. now the many in the local government don't have the enough budget and the electricity. So we discover the new system, tornades or eco-fan. This is there are no needs to the electricity, but this is one of the biological treatment. One of the biological. After then to the chemical treatment, and also might depend on the quality of the leachate. So sometimes we added the another option for the biotope. And this is a very simple method.
We use like stone cascading
yes.
and
Yes,
natural
yes.
method.
Recirculation, yes, also. Hi.
Thanks, Professor. Another important question, which I feel I should ask, which is, what is the minimum size of landfill where this can be applied? We are working on a dump yard with about 20,000 meter cube of waste. Can this method be utilized? This is asked by Arun Ramachandran. Yeah.
小さくして。まあ大きい。
So, and basically, is we recommend to the first try in the 1 hectare or 2 hectare, but in the big city is 4 or 5 hectare is suitable for the economical size. But depend on the your budget of the local government condition. But basically, is no need to the very big area. One section is as soon as possible very small. Size is better. 1 hectare or 2 hectare is better.
Thanks, Professor. There's one common question that I'm receiving, which is, what is the business modality and which, the economic feasibility of this project? What is the mode of operation? How in other countries have you facilitated it? Or if you have an example of any particular city where, so the economics of it, very briefly, if you could share or ensure the business modality for Fukuoka method. What is the most favorable one? Thank you.
なかなか難しい質問だけども、その相談していただければね、その状況に合わせていろんなオプションを提出できると。ただ、やっぱり効果を見るという面ではね、あんまりビッグシティもメトロポリタンみたいなのはちょっと厳しいなということで、1ミリオン、ポピュレーションぐらいがやりやすいですね。
Okay, the professor was saying that it's a very difficult question to answer right away. Of course, in any size city or any state of waste in a particular city, we will try to create a model that will be feasible to fit in the budget and the economy size of that particular city. Of course, as we were saying, it would be relatively easier for us to start with a compact sized city, but we'll try to create a feasible, suggest a feasible model that will be workable within the city's given budget.
Thanks, Sachio. Maybe we can take a few questions from the audience. I see a lot of hands raised. Can our admin give the handle to Abhimanyu Chakraborty? Abhimanyu, can you please ask your question?
Thank you so much for the wonderful presentation. Can everyone hear me?
Yes, you're audible. Please go ahead.
I wanted to understand how significantly have the lives of waste pickers who live around landfills have improved through this method, or have they seen any kind of changes in health measures? I mean, have their lives improved after adoption of this method is what I'm asking. Thank you.
Okay, let us take one example from the one I showed you already from Addis Ababa city in Ethiopia, that there were 2,000 waste pickers from very young children to very old people. And as you know, there's so much different kinds of danger associated with working and living on a dump site. And through our intervention, I think we were able to introduce a system where the waste pickers, the truck drivers, the heavy vehicle operators know how they coexist, so that these terrible accidents, which do occur very quite frequently, make sure that that does not happen, and so that that sort of security, the safety is much better in place now. And throughout this project, we have hired many waste pickers as our daily workers, so that they have obtained much better technical skills as basic engineers. And many of them have found jobs elsewhere, more stable jobs as construction workers, and they had been hired directly by city administration to do basic skill jobs for them. So there's much less number of waste pickers now at the dump site, which I think was an accomplishment that we were able to make.
Thank you, Sachin. Maybe we have time and we'll take a few more questions. Can we give the handle to Dr. Sanjay Sood now? Kindly introduce yourself when you ask the question. Dr. Sood, please proceed.
Yeah, can you just hear me? Am I audible, please?
Yes, you're audible. Kindly go ahead.
Hello, Swatiji, and good afternoon, everybody. I'm Dr. Sanjay Sood calling from Shimla, Himachal Pradesh. My basic question is, madam, that in the presentation was mentioned that you can grow vegetables, you can grow these fruits on these remediated sites. So there are fair chances of contamination of these fruits and vegetables by the radioactive material and the hazardous material that is dumped there. So are such vegetables and fruits, are they fit for human consumption? So I just want to have your reaction on this. Will we actually undertake these kind of interventions?
Thank you, Dr. Sood. A very relevant question.
ただね、腹道の厚さが問題ですね。やっぱり最初の。なので、大体若干のコンタミネーションはね、問題ない。はい。植物の根がね、そういうファンクション。
Usually, these plants, vegetables, and fruit trees, the roots have what is called the buffer effect, and the contamination does not go penetrate to the flowers or the fruits. Of course, we need some thickness of layers of cover soil on top of the waste layers to do commercial farming and vegetation directly on the waste layers, but usually you can be assured that the contamination does not come directly to the fruits.
そのわけにはですね、セグレゲーションというのが重要なんですよ、やっぱり。入れるもの、何でもかんでも入れた後はダメだ。
Thanks, Sachin. We'll take another question, which is from Baswaraj Kabare. We'll give him the portal, and I think they are from Bangalore municipality, and Bangalore has a huge issue of dumping and disposal. So over to you, Mr. Kabare. Can you please proceed and ask your question? Jogesh, can you give the handle to Ms. Vaishali Nandan? I see a hand raised if they have a question.
Yes, so I have a question regarding the economics of it. So what is generally, as a thumb rule, the minimum cost that is required to build such a landfill? It could be dollars, it could be whatever, whichever currency would be most preferred. But it would be good to understand if it's a 1 acre or a 1 hectare, which you say is the most feasible. What would be the cost for a 1 hectare rehabilitation and such a landfill? Thank you.
Thank you, Vaishali. Over to you, Sachu and Professor.
大体普通ね、さっき言ったように、ライフスパンが10年か15年が使えないとフィジブルじゃないよね。うん。発生量に対してね。
Okay. We need
そ
various.
れとね、どれぐらい必要かっていうのはいつも言うように1食、3食を、ぐらい出せたらいいと。レベル3ぐらいまでいくと。
Okay. This, of course, may vary by country, and we have not done any projects in India, so my local calculation might be a bit difficult. But from our experience in Africa in the recent years, perhaps by 1 hectare, it cost us roughly $300,000 to build a 1 hectare new Fukuoka method landfill site. That is including the labor and the construction materials and part of the heavy vehicles cost. It also depends on whether that local government has their own heavy vehicles such as bulldozers and backhoes that we can use for the constructions, but roughly saying it's roughly that range of. And we have to make sure that unless the dump site is able to use for at least 10 to 15 years, it will not be economically feasible. So we have to make a basic calculation on that as well.
Okay,
thanks, Sachu. Maybe I'll ask Shri to come in. Yeah, Shri, over to you.
Yeah, I mean, thank you. Thank you for asking that very pertinent question. This is what we experience whenever we visit countries and meet the mayors or the Minister of Urban Development. So what is the cost? In my experience, in especially working in Asia Pacific, having dealt with similar situations like in India, I feel the cost in India will be much cheaper, cheaper than even Africa, cheaper than in Southeast Asia, cheaper than even the one that is being implemented in Kabul in Afghanistan, for a variety of reasons. Number one, the availability of local material. We have everything available here, be it pebbles, be it boulders, be it gravel or sand. And second, in terms of the human resources, I think even the previous question about how do you link the formal and informal sectors, how do you formalize these rack pickers and the waste pickers and scavengers into a formal economy is exactly the answer. What Sachu has mentioned, the experience in Ethiopia, by bringing all these people who are living on the waste picking and those that are scavenging in and around the city, and formalize them and cluster them in a group and ensure them with the medical and health facilities and also access facilities with occupational safety and health training and insurance cards, medical insurance, and integrating them and linking them with the formal economics of the city, be it a recycling shop or be it a composting facility. So, I mean, there are so many good examples within India. Bangalore is one in the foremost in terms of composting, using varieties of composting techniques, be it vermicomposting and also other catalytic composting. So, I feel that the cost will be much cheaper, and also because the availability of a lot of heavy equipment with the urban local body, especially that you are implementing, I think the world's biggest urban missions in India. So where you have 5 to 6 urban missions being implemented in most of the cities in the last 4 or 5 years. So we feel there is a huge possibility of building synergies with ongoing missions utilizing their resources, be it equipment, be it human resources, and also their network. So I feel that the cost will be much lower to the Indian context. Thank you.
Shri, next and the last question we'll take from Bangalore municipality. We have Mr. Basav Raj with us. Can you kindly unmute yourself and ask your question?
Yeah, hi, I'm Basaraj Kabade. I am from Bengaluru Municipal Corporation. We have a unique site in land disposal. I mean, our sites are deep quarries, these abandoned stone quarries. Nearly 20 acres of land, whereas we have deep quarries. The depth of the quarry raises up to 80 to 100 feet deep. So over the last 4 years, we have been scientifically using this for landfills. So, and most of the nearly around 20 acres or 15 to 20 acres land is almost covered. That is, we have actually reclaimed the whole quarry, and it is up to the ground level. And we have lined the entire quarry before filling. We have a pipe system of collection of leachate, and for gases to go, we have put perforated HDP pipes. And now, and every day we have been doing soil capping over the landfill. Whatever landfilling is done, every day soil capping is done. And at the end of the, when we covered the whole quarry, we filled with 1.5 meters soil. So now the problem is we cannot biomine because we have already reclaimed the abandoned quarry. It has to be only bioremediated. So for bioremediation, we are in the process of inviting tenders. So which will be the best method wherein we can bioremediate and use this site for after 5 years, 6 years, use this site for any park or a playground or something like a racetrack, something we can use it. So what is the best methodology to treat the leachate that is coming out and treat the gases that might come out in near future, next 4 to 5 years? So we are looking out for calling for a tenders for this. So I would like to know which are the best methods to possibly use this 20 acres of land for any good purpose. Because we can't biomine it because we are not reclaiming any land as such.
Thank you, Mr. Kabare. Sachio, did you get the question or do you want me to repeat?
I may have missed the current condition, but what's the final part of the question? How to reutilize the reclaimed land?
I'm very sorry, I was muting. The first half, the sound was breaking, so I may have missed. But the final question was that how to utilize the reclaimed land?
Yes, they have query lands, and then what is the best intervention for them? Yeah, how do they reutilize this land as biomining processes are not working for them?
You are self-muted. Please unmute yourself.
そのモニタリングしてね、それに合わせて、だから抽象いつもよりサーフェス利用とね、中層と3段階に分けてやります、我々は。
そうですね、そうですよね。Okay. I'm sorry that I missed the first part of the question, so I'm not sure if I can answer properly. But in using the land after a closure of a landfill, the monitoring goes on for a long time, and there's certain phases that the land can be reused. The first phase, So the first phase is only you make sure that you utilize only the surface of the land. And the long-term monitoring, then you can start to use a deeper part of the land. So if it's just using the surface as like public parks, playgrounds or such, that's also fine. But if you plan to build buildings or structures or farms, then you would need to make sure that you have a longer term monitoring and check the degradation before you start to use for such purposes. And monitoring has to be done for much longer term from our experience. 福岡でもう40年ぐらいやってるんですよね。
そうです。30年ぐらいに。
In the photographs that we showed you earlier, how the former landfill is utilized into schools and parks and elderly homes, the focus in condominiums, the monitoring is still ongoing after 40 years. Of course, there's very, very few, almost zero gas emission at this point, but it is very important to continue the monitoring, especially when utilization of land involves people activity on top of it.
Okay. So just mentioned that Sachio-san, so in the Fukuoka city, collaborate our university, the very long time for the monitoring. So, and also the Fukuoka city have the technical committee for the evaluation of the stabilization level. Every year, once or every year, we have a meeting for the evaluation of the present condition. So with there are many problems, so we recommend some in the surface use level. But depend on the stabilization level. But every time 3 points. One is subsidence, and second is a gas monitoring. The one more in the corrosion by leachate or waste for the pile or concrete structure. So 3 point is a must monitors, must monitors. This is very important. Depend on the stabilization level.
Thank you, Sachio and Professor. We have a lot of other questions as well, but to save time, we'll jot these down and send them to you for responses. And I assure that all of you will get your responses back. Maybe we'll now take the last poll of this session, wherein we want to know from you, was this intervention, the Fukuoka method, do you think it will be useful method for remediation of dump sites in Indian cities?
Can
we kindly publish the poll? Okay, so I think this definitely tells us that we have a lot to share with you. And of course, we'll definitely discuss within how do we take this forward. But moving ahead, I'll ask Ms. Sachio Hoshino for her closing remarks. And we thank Professor and Sachio for their valuable time. Sachio, over to you. Thank you.
Thank you. Thank you.
Thank you very much, everyone. And excuse me for the technical hiccups here and there. Finally, on behalf of UN Habitat, I would like to express my sincere gratitude and appreciation for your patience and participation today. We are very much honored to have the opportunity to introduce Fukuoka method how it has been found and developed through tough experience and years of research. This is
Welcome to Fukuoka. Ne?
okay. Professor was saying that when the time comes that you're able to visit, he would like to show you around the reclaimed land areas to see for yourself how it has been rehabilitated. So this is not just civil and environmental engineering and technology, but this is science and how its basic principles have been transferred and replicated in many countries and cities around the world. We hope you have found this webinar inspiring, at least somewhat interesting. And we hope today will be the beginning of our engagement relationship with work with you through the UN Habitat SCIAP program or the program for sustainable solid waste management, which is really so relevant and so much at the core of public health and hygiene, in particular at this time of the world, which are all facing. Thank you very much again. Please stay safe and healthy, and we look forward to the day we can meet face to face.
Anyway, everybody be careful for the COVID-19. Ne?
Thanks, Sachio. Thanks to my colleagues. Thanks, Sri, for being here, and thanks to all the attendees for being a part of the webinar. Going ahead, we shall share all the proceedings of this discussion on our UN Habitat India website and over email, and we intend to get back to you for further feedback. We do hope that this webinar was useful to get all the valuable insights from all of you, as well as from our team from Japan. Also, to take this intervention forward, we shall be keen to discuss with a few municipalities on how to take pilots on Fukuoka forward in India. If you'll have any questions or if you need additional information, please write to us at unhabitat.india@un.org. And one thing is very clear from this entire discussion, which is that we don't need more landfills. We need to remediate the existing and ensure that there is sustainable waste management. So stay safe and have a good day. Thank you, everyone.
Thank you. Good to see you. Namaste. Namaste.